All right. Hey guys, welcome back to another video. So today I'm going to be talking a little bit more about the FTC, but the first part of it. So remember from maybe like my last video or like what you guys have discussed in lecture already is that the first part of the FTC kind of just lets us cancel the derivative and the integral, right? But that's not the whole story, right? So basically, the real reason that we want or that we need the FTC one is for something like this. So let's say, as an example problem, I want to take the derivative of the integral from 0 to x of, let's keep it simple, right? We're going to call it t, or maybe 2t, right? dt. Okay, and so this is where it's becoming a lot more important that we're really careful with our work and the way that we write things, right? So notice the variable inside the integrand has to match the variable on the outside, right? So because on the inside it's t, for my integral it has to be dt, right? But notice how I can't actually just cancel things, right? Because this is a dx. So I would have to take the derivative with respect to x, but what's inside of this integral right here is in terms of t. So that doesn't make any sense. Thankfully though, what this integral is telling me is I can substitute an x in, right, by taking this integral, right? And so basically the way that we could work out this like problem is we'll just move from the inside out, right? So let's tackle the thing inside first, and then we're going to deal with that dx on the outside, right? So on the inside, it's going to be a very standard process. So I don't want you guys to freak out because there's like a 0 and an x. Treat them as if they were numbers, right? We're going to go through the same like FTC2 process to get that integral, right? So it's going to look something like this ddx comes down, and it's going to be applied to this integrand right here. So when I take this derivative, or when I take this integral, I'm going to get t squared, right? Because I would have to add 1 to the power and then divide by that power, so I'm going to end up with t squared. I need to evaluate it at x and 0, right? So the way that I do this is I'm going to drop this derivative down again, and this is going to be x squared minus 0 squared, right? So this is going to give me ddx x squared, right? And so now that I have an equation in terms of x, I can take the derivative with respect to x, right? And so this is a pretty standard one. We all know this one, right? So the derivative of x squared is 2x, right? So that's where I'm done. And so this is one of the real big reasons why we need something like the FTC1. It lets us do exactly this process. So that's all I have for you guys today. I hope you learned something. If you want to practice, there's a worksheet. And if you want to still practice more, come see me during my office hours and we can talk about it. All right, thanks for watching, guys.